Hello students, let's discuss the instruction classification of 8085 instructions. So it has got 1-byte instructions, 2-byte instructions and 3-byte instructions. That means each instruction will be of 1 byte. When you code it, it will be of 1 byte or 2 bytes or 3 bytes. Okay, and the fields of this instruction is opcode and operands. It will have an opcode and operands. Okay, opcode will specify which operation is going to perform. Like move, it is a transfer, moving the data from one register to register or from memory to register and all. Okay, add, it specifies that we are going to add using that particular instruction. Operands is on which data it is to be performed. The data may be in registers, or immediately you can specify the data in the instruction itself, or you can get the data from the memory. Okay, so this is the data on which that operation is to be performed. So let's see first one byte instructions. Let us suppose move A to C. Always it is the source and this will be the destination. First we'll write the destination and then the source. Okay, we read it as move A to C, not from C to A. It is move A to C. So with the execution of this instruction, the data which is present in A accumulator, this will be copied to C also, C register. Okay, so to code this one, this is the instruction you are writing. To code this one to binary code or hexadecimal code, then for that purpose you need to look for that instruction opcode from the data sheets, opcode sheets. So in every 8085 textbook it will be given at the given like this. Okay, so here you can see there is instruction increment 16-bit. Okay, simple instructions will take first. Like here you can say move H to B. That means move the data which is present in H to B register. Opcode for this instruction is 44. Because both the registers are there internal to processor, here only opcode. Operands are implied. Like here with this, in this opcode itself, you have the operands. Okay, so in the same way, move C to B, the opcode is 41. So with the execution of this 44, this instruction, the data which is there in H will be moved to B. So let us see an example like move A to C. I have written move A to C instruction. Then I look for the code from these data sheets. So when I see here, yeah, move A to C. The opcode is 4F. So this is the code for move A to C. So I will write the code as 4F in hexadecimal. Okay, so this way I write all the instructions, then code them using this data sheets, the code sheets, and then feed this code to the memory and then tell the processor to execute. That we'll see. Okay, then let's see 2-byte instructions. Okay, 2-byte instruction, you have, let us suppose you have an instruction move immediate data to accumulator. Okay, so here this is a 2-byte instruction. For this move immediate data, 8-bit data to accumulator, there will be one opcode which you will search from the code sheets and you will write that opcode. So the opcode will be move immediate data to accumulator. The opcode is 3EH. 3E. Now opcode is there. One operand is in accumulator. to the register this data is to be moved. So you should specify in the program what data is to be moved to accumulator. So the next byte will be this data. Let us suppose if I write it as move immediate A with 44. Then when I code this instruction, the code will be 3H first byte and 44H second byte. This is the opcode and this is the data. So this is how you convert this instruction to code. Now let's see 3-byte instructions. Okay, 3-byte instruction. Example, I'll take load immediate B with 2000H. Okay, whenever there is immediate, it means the data is present in the instruction. It is immediate addressing. Okay, the data which is to be moved to this particular destination is present in the instruction. Okay, so here this is 16-bit. So here it is understood that we are using the register pair B, C. So when you combine these two registers, it becomes 16-bit register. We'll specify only the first register. Because this is 16-bit, it is implied that you are using BC. So when you code this particular instruction, the opcode will be, for this opcode is load immediate B with the 16-bit register, the opcode is 01H. You see from the code sheets. Okay, if I search from the code sheets, it will take more time. You see from the code sheets whether it is correct or not. Then the next 2 bytes are this 16-bit data. Okay, always in these 2 bytes, first low byte is written. So the next byte will be 00H and the next byte will be 20H. So this is the 3 bytes for this particular instruction. That's why when you code this, this is the code for this particular instruction, which is of 3 bytes. So this is the 3-byte instruction. Now let's see with an example program how actually you'll write the program and execute the program. Okay, so let's take an example program. Program to add 2 8-bit numbers. Okay, so let's write a program, small program to add 2 8-bit numbers. Okay, here for that you can use one register, you should use one number, you should move it to accumulator. So I will write it as move immediate accumulator with the first number. I want to add 2 numbers. Out of those 2 numbers, this is one number. Okay, then you move the second number to any of the registers. One number should be in accumulator, whichever register is free. Like you need to move that data, second number, to any of the registers. Let us move the data 42H to B register. Okay, you want to add these 2 numbers. So add instruction, add. Here in add instruction, accumulator is one of the operands. So you will not specify that in the instruction, but you should specify the other register. So add B. So with this instruction, A plus B is performed and the result will be in A register. Okay, then halt. This is to stop the program execution. This is the instruction to stop the execution. program execution. Now when I code this program, so here move immediate 23 to A, 8-bit data to A. If you search from the code sheets, the hex code is 3E. And what is the other operand here? This is 2-byte instruction, 23. This one. And again for the next instruction, the code is 40, data to B register, code is 06. What is the other byte? Next byte, this data 42. Then for this add B instruction, the code is 80. You verify, you search from the code sheets what is the code for these instructions and code them. Okay, 80. And the code for halt is 76. Okay, so this is how you write the program using the instructions, then code this one using the code sheets, convert this to binary code, which we are writing it in the form of hexadecimal code. Okay, so how we'll execute this program, what we'll do to execute this program. Here I am explaining how to execute using the kit. Usually 8085 processor programs are executed in kit to know, for the student to know the hardware thing and to know it, like what is memory, what is the difference between the memory data from where which is going. Okay, so SDK kit, and this will be helpful for those who are using the kits to execute the programs. Okay, so usually it is SDK 85 system will be used. So in this system there will be hexadecimal keyboard hex key, because you will be entering the data, these codes in hexadecimal. Hex key will be there, then some more keys for enter and for execute, like keys like execute, keys like enter, some more keys will be there. Okay, then you'll have 6-7 segment displays, 4 here and 2 here. Okay, you'll have 7 segment displays. Okay, and you'll have 8085 chip on this board, and you'll have memory chips on this board, read or write, and ROM memory on this board. Okay, so this is how, like, you'll have other IO interfacing devices also, because these are interfaced using IO interfacing. Okay, we'll not discuss that now. These are the basic things which you'll have or you will see and use in the kit. Okay, so in this kit what you will do, first we need to execute this program which we have written here. We have coded that program. Now enter the code to memory. Enter this code to memory. So what you will do, let us suppose we want from the manual of the kit, you can know which memory you can use to, what are the memory addresses which you can use to execute the program. Let us suppose 2000H from is the address which is available, any address whichever is available for execution, 16-bit address. Okay, so let us suppose we take 2000H. So what we'll do here, for entering the program, you'll press a key so that you will be able to enter the digits address here. So you will enter this address 2000H. So when you enter this address, it will ask for what you need in this location. So you will enter the code. So here first code is 3E, so that you will enter here. Say next. So it will go to next location. Here 3 you entered, next you enter 23. In the next location, next byte 06. In the next location, you'll say next and enter the whole program in these locations. Okay, so this is how you will enter the program, this hex codes in the system. After entering the program, your entering is over, then you will tell the using a key called execute, you will say execute. Then it will ask from where I have to execute. Then you will specify the address here again 2000 and say execute. Then it will execute the program which is there in these locations. Because 76 is there in this location, it will stop the execution here. Now after this you can check the result. Where is your result? Result is in accumulator. So here you will have keys for registers. So you press the register A, it will show what is the data that is there in accumulator. So that will be displayed in this field. Understood? So your result may be in memory location also. How you are writing the program depends on that. Then you will go to the memory location and check what is the result present in those memory locations. So this is how you will enter the program using the kit. First write the instruction program using instructions, then convert it to code, hex code with the help of the data sheets or code sheets present, and then enter the program and execute the program and check your results. Okay, you can like there are assemblers also like MASM. Using that also you can execute the program in the system PC. Okay, so there you will enter, there you will not code, you will write the program instructions, you will enter the instructions, then you will say assemble and then execute. Then you can view the result. After execution it will show you all the register contents, so you can verify your result. So this is kit is used for you to the students to introduce the hardware part, and so that it will be clear for them what's going on. Okay.